Okay, today's lesson is on 9.3.1. We're going to be practicing how to convert from a polar coordinate to a rectangular coordinate. And the first way we do this is we kind of create this hybrid combination of an XY plane mixed with a polar axis plane. So this figure will be really important. You'll want to copy it into your notes. And take special note that when we draw a point on this hybrid coordinate system, this point is technically x comma y, which is this length here and this length here, but it's also the radial distance, which is the distance from the origin, and the amount of rotation from the x-axis. So your theta is right here. So what we have is we have this relationship between the x-coordinate, the y-coordinate, the radius of the polar coordinate, and the angle of the polar coordinate. And it creates a right triangle. So we can use basic trigonometry to go ahead and convert from the radius and the angle of rotation back into an x-coordinate and a y-coordinate. And that's what we're doing in our first example. They want us to find the rectangular coordinates for each point with the given polar coordinates. So here they've told you what the radius is and they told you what the angle of rotation is, this part and this part. And they want you to solve for the x-coordinate and the y-coordinate. We can do that using trig, right? If I have the hypotenuse and the angle and I want to find the adjacent side, I would use cosine. So since x is the adjacent side, I would say that the cosine of theta is going to equal the adjacent side x over the hypotenuse r. Okay, and since we're solving for x, we're always going to end up multiplying both sides by whatever the radius is. And so we get this uniform formula for the x-coordinate. The x-coordinate would just be equal to the radius times the cosine of the angle theta. Okay, and we could do the same setup if we just use sine instead. We would say that the sine of theta is equal to y over the radius, but we're going to end up multiplying both sides by the radius again, so we'll get that y is equal to r times the sine of theta. Okay, and that's what these two equations come from right here out of your textbook. And then the short way of writing it as an ordered pair would be to take the x-coordinate, which is r times cosine theta, comma the y-coordinate, which is r times the sine of theta. So I'm going to take each of these coordinates and we're going to practice converting them from polar form, converting them back into rectangular form. This coordinate has a radius of 4 and is rotated 30 degrees. If you're not comfortable with the radians, you can always convert them into degrees. This would be 4 rotated 30 degrees. And so now we're going to use our formula to convert this into an x-coordinate and a y-coordinate. So the formula is the radius 4 times the cosine of 30 degrees, and the radius 4 times the sine of 30 degrees. So if you get an angle that's on your unit circle, you can use your unit circle. In fact, I would encourage that. That way you get an exact answer. So since we have 30 degrees here, we don't have to use our calculator. If we look on the unit circle, the cosine of 30 degrees is the square root of 3 over 2. So this is 4 times the square root of 3 over 2. And this is 4 times the sine of 30 degrees, which is 1/2. So this is 4 times 1/2. Some basic simplification. This gives us 2 radical 3. And this just gives us 2. Okay, so that's your x and y coordinate. That's how far over and up that coordinate is on the polar axis. Let's try B. The only difference between A and B is that B has a negative radius, and so we kind of want to think about what quadrant we're supposed to be in. If we have a negative radius, we start on the left side of the pole. So I'm going to be starting over on this side, and rotating 135 degrees positively puts me in the 4th quadrant, way over here. So sometimes it's a good idea to mark which quadrant you're supposed to be in. We're supposed to be in the 4th quadrant here, so at the end I need to make sure my rectangular coordinate is also in the 4th quadrant. So for this one, we're going to get negative 2 times the cosine of 135. And this is going to be negative 2 times the sine of 135. Again, an angle measure that's on our unit circle, so we'll get the exact ratio for these. This is negative 2 times, for cosine, this will be negative square root of 2 over 2. And for sine, it's just positive square root of 2 over 2. Okay. Some simplification, negative times negative is positive, and the 2's cancel out, so this is just positive square root of 2. And negative times the positive is negative, but the 2's still cancel out, so we have negative square root of 2. And we are, in fact, in the correct quadrant, quadrant 4. If I go positive x and negative y, that puts me in the right quadrant, so that checks out. Okay, our last one, we have a negative angle. If you want to get rid of the negative angle, don't forget you can find a coterminal angle by adding 360 to it. That would convert this to a little bit easier. This would be 3, 240 degrees. It's the same exact coordinate. So this is a little bit easier for me to convert into rectangular. I'm going to do 3 times the cosine of 240, which, by the way, 240 is in the third quadrant, so that's what we'll check when we get to the end. And then 3 times the sine of 240. The cosine of 240 is equal to negative 1/2. So this is 3 times negative 1/2. And for my other coordinate, the sine of 240 is negative square root of 3 over 2. Okay, some basic simplification. This is negative 3/2, and this is negative 3 square roots of 3 over 2. And both of my coordinates should be negative since I'm supposed to be in the third quadrant. Okay, that's how you convert from a polar coordinate to a rectangular coordinate. The coordinate doesn't change location, it's just being described differently. Try these 3 on your own. Here are the answers you should get. Alright, the other thing we're going to learn today is how to convert in the other direction. If we have a rectangular coordinate and we want to convert it into a polar coordinate, we can use the same figure that we had before, but now we're being given these 2 sides and we have to find the radius and the angle. So if I have 2 sides of a right triangle and I want to find the hypotenuse, I can just use Pythagorean Theorem, which is what we have right here. Remember, r squared, which is the hypotenuse, should equal x squared plus y squared. All they did was square root both sides to solve for r. And then to solve for theta, right, since we have the opposite side and the adjacent side, we can use the inverse tangent. If we take the opposite side, which is y, make sure you always take y, and divide it by x, that'll be the ratio for tangent, and we can use the inverse tangent. Unfortunately, don't forget that the inverse tangent has a restricted range. It's only going to give you values from negative 90 to positive 90 in your calculator. So if you have a second quadrant or third quadrant coordinate, you need to add 180 degrees to your solution. Okay, and that will place the angle in the correct quadrant. So always be mindful of which quadrant you're supposed to be in. In fact, that's the first thing we're going to do in example A here. We have the coordinate 1, negative square root of 3. So that means I moved positively to the right 1 unit and down square root of 3 units. So that's going to put me in the fourth quadrant. So luckily I'm in the fourth quadrant. I'm not going to have to mess around with the 180 degrees because I'm not in the second or third quadrant. But we should still double check to make sure that when we get our polar coordinate that we're in the fourth quadrant. So the first thing we need to find is the radius. So we're going to say that the radius is equal to, using this formula up here, the square root of my x coordinate squared, so that's 1 squared, plus my y coordinate squared, which is negative square root of 3 squared. And so you end up getting r is equal to the square root of 1 plus 3, which is the square root of 4, which is 2. So that's my radius. And now I need to solve for the angle of rotation. So we're going to use our theta formula. Theta is equal to the inverse tangent of y over x, and the y coordinate was negative square root of 3. And the x coordinate was 1. So if I take the inverse tangent of that ratio, that gives me, in my calculator, it'll tell me if I'm in degrees, negative 60 degrees. Or you could actually look for this on your unit circle. You would see that this is also on the unit circle at 300 degrees. Notice that these are coterminal, so you can use either one. For our final answer, though, we just need to write the polar coordinate. It would be 2. We'll use 300 degrees. Now the textbook asks for you to give 2 pairs of coordinates. Personally, I don't care if you want to write them both out, but really if you give me one, that's good enough. Because you can always just add or subtract 360 to get a second pair of polar coordinates. Okay, but 300 degrees is in the fourth quadrant, so I know that that's correct. And let's try t now. So we're going to do r is equal to the square root of negative 3 squared plus 6 squared. So we get that r is equal to the square root of 45, which simplifies to 3 radical 5. So that's my radius, and I need to solve for theta. Theta is going to equal the inverse tangent of the opposite side, which was 6, over the adjacent side, negative 3. This one you have to put in your calculator. It's not on the unit circle like negative square root of 3 over 1 was. So when you put this in your calculator, you'll get an approximate answer. Go ahead and round to 2 decimal places. You should get negative 63.43 degrees. Okay. Now, negative 3, 6. If we looked at this original coordinate, negative 3, left 3, and up 6 is actually in quadrant 2. So we're in trouble because negative 63 degrees is not in quadrant 2. So this is one of those situations, right? We talked about that if you're in quadrant 2 or 3, you're going to have to add 180 degrees to your angle. So we need to add 180 degrees to this, and that will give us an angle, theta, equal to 116.57 degrees. That is in the second quadrant. So that's my answer for my polar coordinate. 3 square root of 5 for the radius, 116.57 degrees for the angle of rotation. Okay. Try these last two on your own. There are the solutions. 2a was in the first quadrant, so you didn't have to modify the angle. But 2b was in the third quadrant, so when you got your inverse tangent angle, you needed to add 180 to it. Make sure you leave your radius in exact form, so leave it in radical form. Okay, here's the corresponding assignment with this lesson. That's it for today. Have a great night.